I've put together a basic guide on how to write notation and some hints for working on equations. You can look at this as its own assignment, or not assignment. You can look at this as its own slideshow. You don't have to follow along in the video, but this will explain it to you to make it a bit more sensible. We want to develop notational habits that help us, not drag things out, but actually be of use. You're gonna learn a lot of Greek letters. Not a terrible lot. You gotta learn delta. You already know it. You know pi. I'm adding sigma to it. Sigma means sum. Lambda is going to be wavelength. It's supposed to be spelled with a DA, but Google Docs also recognizes it as just lambda. Tau is small letter t. You'll be using that in university. Capital letter T is for tension or period. The type of T I've written here is called a serif. Serifs are letters that have these little drop features and little corners on them. A sans serif letter is like the letters in here, or this letter T, where it's just very much a stick figure. We always want to use the serif form. It makes it clearer. And F is not a Greek letter, but it's for frequency. And we don't want plain letter F. We want a nice scripted one. If you've programmed your Google Docs to do these substitutions, life will go a lot easier for you. I may use small letter delta, small d, and epsilon, the small e, for error. So sometimes we say we measured x plus or minus epsilon, and you will eventually be using that in university. The sigma notation, we're going to use that every single day, okay? It just means you've added it all up. Next is scientific notation, exponential, engineering, and floating point. The difference is simple. When you write 10,000 out, your calculator may spit it back at you as 1 times 10 to the 4th. This is an exponential form. But how do you say 10,000? You say 10,000. Let's look at it again. That's 10 followed by 10 to the 3, 10,000. But if we write it out without this bundling, what if I put the comma here? You'd go, well, what the heck number is that? That's 1 10,000. It's still correct. English would allow you to say, I need 1 10,000. But it sounds really stupid. And you automatically know to bundle it in 3s. So you don't actually want to say this 1 times 10 to the 4th because it's 10,000. But if I write it like this, you might stare at it and go, oh, that's 10,000. And after all, that's what you wrote here, 10, comma, 3 zeros. Why did we ever teach you that? It's to bundle it. The cat is on the piano again. So scientific notation just simply allows the spoken word thousand, million, billion to be named and bundled with. So if your calculator says 1 times 10 to the 7th, this is the number. But writing 7 zeros in a row not only looks wrong, you can't even read that number, can you? Not at first glance. I know it's 10 million because I'm smart. But if I let you put the commas in, you immediately, oh, that's 10 million. But you could have said 110 million here. So you would automatically bundle it and perceive it to be the number 10 followed by a million. You're actually carrying out scientific notation in your head. You just didn't know you've done that. So what you're doing in your head is this. You see the 10, and then you bundle the 6 zeros in your head, and you call it million. And that's all that scientific notation is doing. All the rest, all the practice is gobbledygook. But ultimately, scientific notation is about turning English words for numbers into prefixes, avoiding the ones that do not have a name. 6 zeros, or 10 to the 6, is million. And in metric, we call it mega. So this number would be written 10 with a capital M after it. What numbers do we have names for? Hundreds, thousands, millions, billions. So scientific notation chooses a prefix that allows us to speak these bundles. 10,000 is 10,000. And 10 times 10 to the 3 is literally saying 10 thousands. But if you look at 1 times 10 to the 4, it would read to your brain as 1/10,000. So even though these two numbers, 10 times 10 to the 3 and 1 times 10 to the 4, are actually the same number, it is only 10 times 10 to the 3 that lets us speak it in plain English. So we replaced the 10 to the 3 in the old days with the word grand. And you'd go, oh, 10 times 10 to the 3, that's 10 grand. But in science, we prefer Latin. So the grand becomes kilo. And we go 10 times 10 to the 3 becomes 10K. And you hear both short forms now in English. When I was a kid, I only ever used to hear my car cost me 20 grand. And you immediately went, oh, 20,000. But now you hear people say, yeah, that car cost me 20K. Here are the available prefixes that we will use mostly in this course. Milli, centi, kilo, mega, giga. And the prefixes. You read billion, million, thousand, hundredth, and 1,000th. We use some others. Do we have one for 10? Yeah, never caught on. It's called a deca. And the only time you use it is in the word decade. Now, how does your calculator handle this? Your calculator comes with a key. The key will be labeled FSE, F arrow E. It might say fix, psi, X, flit, psi, and X. They all do the same thing. Another is fix, psi, ing. All these are doing is telling you what kind of exponential mode the calculator will go in. So floating point, you type in the number 12764, and it will just leave it like that. Plain old ordinary number, floating point. Some calculators call it fixed because you can specify in the calculator how many digits. So if you're working in a bank, you would go fix 2 digits, and it would just report 12764.00. Okay? We don't need to worry about that. Scientific mode will force an exponent of 3 on it. Every number will get that exponent. It'll go to the nearest number that has a name. And in this case, it happens to be 12.764 thousand. Exponential mode will drop every number to 1 digit and put it in a form that has no short form. So you're stuck saying 1.2 blah times 10 to the 4th. You can't say, it's 1.2 10,000s. People won't understand you. That's why scientific is preferred. Ing mode, engineering mode, is for engineers. They are horrible people. They have no social lives, and they build things that fall down, and we're not going to talk about engineering mode. Now, calculator I use on my cell phone is called Hypercalculator. It was an app worth, I don't know, was it like $4? I really love my Hypercalculator because I can't stand the Windows calculator. So Hypercalculator has really helped me out of my phone because my phone's calculator sucks. Okay? You need to become friends with exponential notation now. If I say 10 grand, you know I mean $10,000. If I say 10 kilometers, you know that this is 10,000 meters. But what if I say 1 billion meters? Do you really want to write out 10, 1, 2, 3, 1, 2, 3, 1, 2, 3 meters? Do you think I want to count those? I'm 57. My eyes are blurry. They start to look like little centipedes. Don't do that to me. No, use a prefix and write 1 gigameter. But on a calculator, it's not going to take gigameter. So you're going to have to write it as 1 times 10 to the 9th. And you're going to fight me on this. You're really going to want to put all those zeros in, and you're going to make this old man get like eye cramps, and I won't be able to focus, and I'll hate you. So you need to get down with the scientific. And you know why? You know why? You really want to write these numbers out? Do you, kid? Huh? Well, you're going to start using the mass of the earth, 5.97 times 10 to the 24 kilograms. And that's what it's going to look like when you write it out in full. Do you want to count those zeros? I'm not going to count them. And what happens when you start using the mass of the electron? 9.11 times 10 to the minus 31? You're really going to write that number out? I bet you don't even want to count and see if I actually put in the correct number of zeros. No, It's going to be a nightmare next year. Get your scientific notation down. How are you going to write this out? You're going to be like one of those like ancient Egyptian papyrus scrolls with the 2 rollers, and you're going to have like a notebook that looks like a roll of toilet paper. Stop writing all the zeros. Start with the scientific notation now before it slaughters you next year. Anyway, to continue, I've asked you to program in some nice short forms. I've made the substitution list. I've already made a new document, so we don't really need to discuss this one much. Just look at the screen. This is what I want to stop seeing. 5 meters a second, x, 6s. It ain't me you're punishing. You're going to make mistakes. You're going to make horrendous mistakes if you keep writing this way. Okay? Look what happens. Oh, you were trying to divide something by something, except now you no longer can tell which one is a division and which one means per. It looks a little bit better here. It looks best here. Okay? You gotta stop using the time symbol for multiplication. It's going to cause you grief. Now, when you write out variables, look at this, x times y. Is it x times y? Is it xxy? Is that chromosomes? Are we doing biology? What is that? Oh, x footnote y. I don't know. Is that x footnote y? Oh, I'll try this one. X times, well, that looks awful. So does this one. But look how pretty that looks. Look how pretty that looks. Look how pretty that one looks. Don't do this to me or you, okay? If you don't want to do brackets, type that word mid-dot and you're off to the races. I've given all of you these things to put into your Google Docs, or you can access them directly from this menu. And inline division, same thing. If you want to write a formula on a straight line instead of equation editor, now you should be able to put in the division sign. Some days when I'm tired, I like this more than that because there's an awful lot of slashes in meters per second and stuff. So sometimes I actually go for the division sign just to break the screen up a little bit. Now, this is going to be a big marks killer for a lot of you. I'm not saying that to be mean. I'm saying you got to get this under your hood. When numbers become really big, it's going to be hard for you to do anything numerically. You will not see general relationships if all you're doing is plugging in numbers. You won't discover new relationships or formulas. You won't be able to prove anything, and it will block you from canceling out common quantities and making life simpler. What do I mean by the difference? Let's suppose between algebraic and numeric substitution, let's suppose I gave you this formula that we'll be starting on by Thursday or Friday. Acceleration is the change in speed over time. And I say to you, I want you to solve for time, and I've given you all the numbers to solve for time. You rearrange this formula to this. Then you plug into your numbers. That's the way it should be done. Rearrange first, then stick in your numbers. But some of you are going to do this. You are going to write out the numbers, and way at the end here, there's your letter T. You're going to try to put this all together and get your answer for T, and you will get lost and you will screw it up. This kid could still screw this up. They could put in the wrong numbers and get messed up, but at least I know they rearranged successfully so they've got part marks. This kid here is going to get lost. How come this doesn't work when it used to work in math class? It's real simple. In math class, these numbers, I didn't put this up here yet. I'm still making the slideshow. Pause it. It disappeared on me. I had it all set up there. So it's down here in the reading. In math class, you might have 5x plus 4 equals y, and then the teacher tells you y equals 3. So you plug in 5x plus 4 equals 3, and then you go, oh, I can solve for x now. But what happens in physics? Why does it become impossible to do numeric substitution in physics? Because these are not buck-naked numbers anymore. They've got units attached, and when you see this meter/second squared time, you're going to lose track of letters, guaranteed. And the other thing in math class, it's very rare the teachers gave you equations to solve where you had decimal numbers. You had whole numbers. So 5x plus 4 equals y. That is easy to solve by directly substituting the numbers in. But not here where there are units and lots of decimals. And again, you don't see relationships. I won't give you an example of that. We'll learn it along the way. This is another common mistake. The unit or the concept being measured get confused. Give you an example. Distance is the idea or concept, but meters is the unit of measure. But they could be furlongs, they could be fathoms. Therefore, they could be, I'm winging it at the same time I've written it. So the idea of distance is the same everywhere in the world, but how you measure it may not be. Therefore, if you write d equals 3 meters, this expresses the idea that distance has a measure of 3 meters. But what I often see from a lot of students is m equals 3 at the end of the equation, which I guess in the student set it means, meters equals 3. And look at that. I'm forever tampering with my work. So I have a high rate of mistakes because I have a higher rate of creation. And so I will be kind to you. The more you create, the more mistakes you make. So you got to avoid this. I see this quite frequently from people that are struggling with their math. They change the idea to its measure, and then they literally get lost. And I've had them at this point write m equals 3 kilograms because they're like, blah, 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 blah. You're confusing. Look at it, right? Your pay is in dollars. Distance is in kilometers. The idea never has units that have the same thing. Nobody says, what distance are we traveling? Oh, we're traveling 10 distance thingies. How far have we traveled? 10 Ds. No, I don't know. The unit has a different name than the concept it is measuring. And so some of you will get to distance equals 3 meters, no problem. But here's where I start to see it later. The acceleration formula, F equals ma, or Newton's law. And I give you a problem. Calculate the force on a 10 kilogram object accelerating at 3 meters per second. And the student will do this. F equals ma. And for some really weird reason, the letter F suddenly changes to N for units. And they write 10 kilograms times 3. And before I do it, they have Newtons equals 30. And I'm like, what are you talking about? And that would be like saying, how far is Toronto from Orangeville? And you go, kilometers equals 80. You can kind of guess what the person just said, but it's coming out highly odd. And this arises frequently from students who do this. The kids that want to substitute in the numbers along the way and then try hopelessly to find that letter also tend to do this. So we really got to break you of that habit. It's not something I'm doing just because. There's a very significant drawback to this. Okay, so the best way to avoid this is make sure you understand what it is you are trying to solve for, the concept, and keep the concept in your head separate from the units. Right? Your weight or mass is the idea, and we measure it in kilograms. Only hillbillies say, my wife, she's a whole lot of kilograms. You know what they meant, but seriously, keep it in the Smoky Mountains, that kind of sentence structure. Okay, so this is a brief introduction to the kind of units I'd like to see, and I expect for a lot of you to fine-tune it along the way. It's not something you're going to go away with right off the bat. But you can come back to this when you're, say, working late at night and you want to go through it. And you don't have to listen to my long-winded YouTube video. You can just go ahead and go to the slideshow directly. Anyway, that's all for tonight. We'll see you tomorrow.